Hello students, in this video we will discuss some more questions of exercise 12.3. So let's take question number 10. In this question it is given that triangle ABC is an equilateral triangle and taking A, B and C as centers, circles are drawn with the radius half of the side AB which touches each other. So from this figure we can observe that, let's take this is R, then if we consider side A of triangle ABC as A, then A will be equal to 2R. Now in this question, one thing is given that area ABC is 17320.5 centimeters square. Now what we need to find out? We need to find out the shaded area. So for that we can consider that if we find area of triangle ABC and we subtract the area of these three sectors, then this will be required answer. So for that we need this radius which is not given to us. So first we will find out radius. So as it is given that area of ABC is 17320.5 and we know that ABC is an equilateral triangle. The formula for which is √3/4 a square. Now put the value is given. So now it is given in the question that √3 is 1.73205. So we have put that value. Now we have observed that A equals to 2R. Now put the value of A as 2R. By simplifying it, we get R equals to 100 centimeter. Okay. Now that we have discussed, to find the shaded area of ABC minus 3 into area of sector. Now we have radius. As triangle ABC is equilateral triangle, so theta will be 60 degree because each angle of equilateral triangle is 60 degree. So shaded area is area ABC minus 3 into area of sector. Area of ABC is given. Area of sector is theta upon 360 into pi r square. Now put the value of theta and r. By simplifying it, we get required area is 1620.5 centimeter square. Now let's take question number 13. In this question the figure is shown and it is given that OPBQ is a quadrant and OABC is a square whose side is 20 centimeter. We need to find out the shaded area. For that what we will do? We will subtract the area of square OABC from the area of quadrant. But for that we must have the radius of this quadrant which is not given to us. So first find out the radius of the quadrant. As it is given that OA is 20 centimeter and OB, which is the radius of quadrant, is the diagonal of square, and we know that diagonal of square is a√2. As A is 20, put the value of A, then we get diagonal of square, that is 20√2, which will be the radius of quadrant. So we have the radius of quadrant. Now shaded area will be equal to area of quadrant minus area of square OABC. Area of quadrant we know that pi r square upon 4 and area of square is a square. Now put the value and after simplifying it we get the required answer as 228 centimeter square. Now next question is question number 15, which is very important question. This question number 10 is also very important. Now question number 15. In this question it is given that ABC is a quadrant and taking BC as diameter, a semicircle is drawn. So this BCP is a semicircle and we need to find out the shaded area, and it is given that the side AC and AB are 14 centimeter each. So first of all we need to find out BC. By applying Pythagoras theorem we can find out BC equals to 14√2 centimeter. Now this implies, now it is given that radius of quadrant, that is we represented by capital R, is 14 centimeter. Now BC is the diameter of semicircle, so radius of semicircle with the diameter BC will be 14√2/2, that is 7√2 centimeter. Now to find out the shaded area, we need to see that how we can find out this area. So first of all we can consider that I have drawn this complete figure. We can observe this complete figure is shown here but the shaded part is not shown. So in this figure we can see that the first part is triangle ABC and the second part is a semicircle whose diameter is BC. So by adding these two things we get the complete area of the figure. And अगर हम क्या करें उसमें से इस quadrant का area subtract कर दें, then we will have definitely the shaded area. So for that means what we get, if we add area of triangle ABC plus area of semicircle on diameter BC, then we get the full area, that the full figure. And उसमें से हमको क्या subtract करना है, the quadrant, that is minus area of quadrant. So we get the idea that how we can find out the area. Now area of ABC will be 1/2 AC into AB, and area of semicircle, that is pi r square upon 2, and area of quadrant is pi r square upon 4. Now put the respective values, then we get required area is 98 centimeter square. Now let's take next question, that is question number 16. In this question it is given that ABCD is a square, and as it is shown that, let's consider this is point P and this is point Q, which is not given in the question, but we are assuming it P and Q for our convenience. Now ABPD is a quadrant and CDQB is also a quadrant, and the shaded part which is shown is the common between both the quadrant. We need to find out this common area. So by joining BD, we can observe that this shaded part is divided into two segments. For the convenience, I have drawn the supplementary figure here, that we can consider that this ABPD is a quadrant. By joining BD, we can observe that this is a segment, and in this figure we have two same segments. So required area will become 2 into area of segment. Now this side AB will be the radius, and we can see that this is a square, so area will be theta will be 90 degrees, so we have theta and r. Now required area is equals to 2 into area of segment. If theta is 90 degrees, then we can apply this formula for the segment, that is theta upon 360 pi r square minus r square upon 2 sin theta. Now put the value of theta and r. By simplifying, we get 256 upon 7 centimeter square. Thank you.